Distributed workloads and application often spans multiple regions and cloud environments. Connecting these machines securely while maintaining low latency communication and controlling outbound traffic can be complex. Traditional VPNs and manual tunneling setup require extensive configuration, and missteps can expose services or lead to network inefficiencies. This is exactly where NetBird comes in. By creating a peer-to-peer private mesh network, it allows machines across region to communicate securely, automatically handling encryption and net traversal. Hello everyone, I'm Sanskriti Hanmukh, a developer relations at Vultr, and in today's Tech Talk, we will explore what NetBird is, its core components, and see how it works in action. We'll demonstrate self-hosting NetBird control plane on Vultr, add peers to a private mesh, and configure exit node routing for centralized outbound traffic. So, without any further ado, let's dive right into it. NetBird is an open source peer to peer VPN platform that allows us to interconnect machines across distributed environments. Unlike traditional VPNs, which typically rely on a centralized server, NetBird leverages a mesh networking architecture built on top of WireGuard tunnels, enabling encrypted low latency communication between nodes. It also handles NAT traversals using turn and stern servers, so peers behind firewall and NATs can connect without manual port forwarding. This makes network seamless and reliable across cloud providers, office networks, or home setups. Finally, the control plane provides centralized management. It handles peer registration, setup keys, distribution groups, and optional identity provider integration, giving administrators full visibility and control over the mesh. Let's break down the core components that make the system work. Management service is the brain of the control plane. It orchestrates peer onboarding, configuration distribution, and group management. All the peers connect with this service for setup and policy updates. The peer agent is a lightweight NetBird client installed on each machine that handles establishing encrypted WireGuard tunnels to other peers. Essentially, it transforms a machine to a fully functional node in the private mesh. The signal service facilitates peer discovery and net traversals. Even if peers are behind firewall or on a different network, signal service ensures that they can find each other and exchange the metadata necessary to build direct tunnels. When direct peer-to-peer connections aren't possible, the turn server relays traffic securely between nodes. This guarantees connectivity even in restrictive network environment. Authentication and setup keys provide secure registration of peers. You can use browser-based login via an identity provider or pre-authorized setup keys for headless servers and automated deployments. This ensures that only approved machines can join the mesh. Let's now look at how NetBird Private Mesh functions at a high level. At the center is the control plane, which hosts the management service, signal service, turn server, and an optional identity provider. Its job is to orchestrate peer registration, configuration, and authentication, but it does not carry any user traffic. Now, this is how the flow works. When a new device joins the mesh, the installed NetBird agents registers with the management service, fetching its configuration and policies. The signal service then helps peers discover each other and exchange the metadata required to attempt a direct WireGuard connection. If they succeed, traffic flows securely between peers with end-to-end encryption. But if a direct path isn't possible due to a firewall restriction or NAT, then turn server steps in as a fallback, securely relaying traffic to maintain connectivity. Optionally, some peers can be designated as exit nodes. When configured, other peers can route outbound traffic through these nodes. This architecture ensures that all devices in the mesh communicate securely and efficiently with the control plane managing the network. Now that we have covered how NetBird builds a private mesh network and the key components involved, let's see it in action. We'll walk through self-hosting the NetBird control plane on Vultr, adding peers to the mesh using setup keys, configuring an exit node, and observing how traffic from another peer is routed securely through it, demonstrating real-world private networking and centralized outbound routing. Before we dive into the live configuration, let's quickly look at what we need in place. For this demo, we'll use 3 Vultr Cloud Compute instances, one deployed in Delhi NCR region to host the NetBird control plane, whereas other 2 in Amsterdam and Atlanta region that will act as peers. We also need a public domain pointing to Delhi NCR instance's IP address. I've already configured that in the backend. With these prerequisites ready, we can move on to deploying NetBird control plane on Vultr and adding peers to the private mesh. Let's start by remotely accessing our Delhi NCR instance. Since our NetBird control plane needs to serve a web dashboard, accept management traffic, and handle peer-to-peer communication, the first thing we do is prepare the firewall. For that, we are using uncomplicated firewall on Ubuntu to explicitly allow the required ports. Notice that these ports are split into three major categories: web traffic to serve management UI and issue Let's Encrypt certificates, control plane service for peer management API communication and gRPC, and peer connectivity used by turn servers to help peers behind NATs establish tunnels. After opening the rules, let's reload the firewall to apply changes. One last time, check that everything is active. Once confirmed, let's move on to our next stage. NetBird ships as a set of Docker containers, one for management service, one for signaling, and one for turn servers. So, before installing Docker itself, we need a few foundational packages. For example, CA certificates for verifying HTTPS connection, curl for downloading files, GNU PG for handling keys, and LSB release to fetch the correct repo based on Ubuntu version. Now we'll add Docker's official GPG key into keyrings folder for secure package verification. Next, we register Docker's stable repository for Ubuntu so we can pull the latest supported engine and plugins. Now that the repo is ready, it's time that we finally install Docker. Alongside Docker engine, we also install BuildX plugin for advanced builds, Docker Compose plugin to run multi-container stack, and JQ for handling JSON responses when scripting. We now enable Docker to start at boot and add our user to the Docker group. This allows us to run Docker commands without sudo, which is more practical in day-to-day workflows. If permissions still don't apply, you can log out and back in. Next, let's quickly confirm the Compose plugin is available, since NetBird's installer uses it under the hood. Now comes the key step, which is deploying the NetBird control plane. We'll start by exporting the environment variable for our domain. Please ensure that you have configured your domain either using Vultr DNS or your domain registrar's DNS setting. The key is to create the necessary A record pointing to Delhi NCR instance's IP address. Otherwise, Let's Encrypt won't be able to issue the certificate. The NetBird team provides a one-liner script that automatically deploys the full stack, including the management service, signal service, turn server, and the default identity provider Zeta on target instance. Once the script execution completes, NetBird is ready to use. In the terminal, you will see a username and password generated. Copy them and store them securely. Then, visit your domain. Here, use the credential to log into the admin panel. When prompted, update your password. Now that we have our NetBird control plane running, the next step is to connect our peers to this private mesh. The most secure and scalable way to do this is by using setup keys. Think of setup keys as pre-authorized tokens. Instead of manually approving each peer or logging in interactively, we generate a key once and reuse it to automatically enroll servers, especially useful for headless servers or automated environments. To proceed, first go to the setup keys section and here click on create setup key. Provide a descriptive name to your key, for example Vultr servers. Optionally, enable make this key reusable feature to set a usage limit. This indicates the number of peers this key can register. Once done, click on create setup key. Copy the generated key and store it securely. Let's close the modal and execute our next steps. Now to add each machine to the private mesh, we need to install the NetBird agent. Let's start by setting up our Amsterdam peer. The agent is a lightweight client that establishes encrypted WireGuard tunnels, manages connectivity, and prepares the peer to connect to our control plane. Once installed, bring the peer online by registering it against the self-hosted control plane using the setup key we just created. Now, I'll repeat the same steps on the Atlanta peer as well. Now to verify that both peers have established their identity and joined the private mesh, let's head back to the admin panel. Here, switch to the peers tab and you'll see the added peers listed as online, confirming the setup. Each peer is also assigned a mesh IP address that you can review by simply clicking on the peer. If you prefer a more interactive workflow for registration, proceed with the browser-based login by following the steps outlined in the supporting reference guide linked in the description below. Now that both the peers are online in the mesh, let's set up Amsterdam peer as an exit node and route all traffic from Atlanta peer through it. This gives us a single controlled egress point, which is great for auditing, traffic filtering, or even geo IP masking. To configure, from the peers tab, select Vultr AMS. Scroll down and choose Setup Exit Node. Here, create a distribution group. We'll call ours Atlanta nodes, which will hold any peers that should route traffic through this exit node. Next, switch to name and description and provide an identifier. Click on Continue, stick to default settings, and proceed with Add Exit Node. Our Amsterdam peer is now configured as an exit node. Now let's add our Atlanta peer to that group. Back in the Peers tab, select Vultr ATL. Here, under Assigned Groups, select Atlanta nodes. Once chosen, click on Save Changes. From the accessible peers, we can verify that Vultr ATL will now push all the outbound traffic through Vultr AMS peer. Now it's time to test whether the traffic through Vultr ATL is really being routed through our Vultr AMS exit node. We are currently connected to Vultr AMS instance. First, we need to allow Vultr AMS nodes to forward traffic between its interfaces. Without this, the server won't actually pass packets from one peer to the outside world. This sets the kernel parameter for IPv4 forwarding immediately. To confirm it worked, let's check the value. You should see 1 here, which means forwarding is enabled. Next, we need to ensure that traffic leaving Vultr AMS looks like it is coming directly from this server's public IP. This is done with a masquerade rule in IP tables. This command automatically detects the correct outbound interfaces and applies NAT so that packets from peer get routed out to the internet. Finally, let's watch the traffic flow through this NAT rule in real time. This will confirm that traffic from Vultr ATL is actually being routed through Vultr AMS. These refreshes frequently, showing the counter for packets in bytes processed by the masquerade rule. As Vultr ATL generates outbound traffic, these counters increment every second. For example, right now the packet count is 57 and the byte count is 4446. As we progress, you'll see these numbers increasing. And with that, we have walked through a full life cycle of setting up a secure private mesh with NetBird on Vultr. To revisit these steps or explore additional use cases, refer to the supporting reference guide linked in the description. To summarize, self-hosting NetBird on Vultr lets you build a secure private mesh network, manage peers centrally, and route traffic through designated exit nodes for auditing or egress control. If you're ready to try this yourself, then deploy your own NetBird control plane and start connecting peers on Vultr by claiming $250 in free credits on a new account using the promo link attached in the description below. For any question or to connect with other users exploring private networking on Vultr, join the conversation on Vultr Community Forum. Thank you so much for tuning in. We hope this tech talk helped you streamline multi-region private networking deployment.